We are now still missing the functionality that our bird's animation also stops when we hit a block, and not just the edge. We are back in our game scene class, and specifically in the extension for the SK Physics Delegate protocol, where we can add this. We will obviously need to add this to the case where we test the contact between the bird and block categories. But since we also test for contact between blocks and the edge here, which as of now has the same result, I will have to explicitly check if there is a bird node that we need to stop animating. We can easily do that by writing if let bird is contact.bodyA.node as bird, and then I want to set bird.flying to false. I will also have to check else if let bird is contact.bodyB.node as bird. And if that gives us a bird, we will do exactly the same. So bird.flying is false. We just check whether either the body A or body B node is a bird instance, in which case we set its flying property to false. We can't just use the bird property here, since we must avoid setting the flying property to false if the contact is just happening between a block and the edge, which will also execute this case. Let me give you a little swift crash course, or maybe a refresher, since I'm sure most of you will already know this. Our bird is a class instance, which when assigning it to this constant bird here, does not get copied, but we just create a new reference to this one instance. If we then set the flying property to false, this will obviously also set it on the bird property, since it references the same exact instance. Alright, this was just a solution for the last video, and we will now think about how we can really work with different levels in our game. We already have different levels in our SKS files, where we can just add new ones really easily and just edit them visually. But we do later on want to set other things for the level too. Maybe in some way specific which birds we have available in a certain level. As of now, we have a property birds in the game scene file right at the top, which is an array of different birds. But this array has just 3 hard-coded bird instances. So in each level, we will have these 3 birds in this exact order. It would be much better if we had a possibility or an opportunity to solve this more like in the original Angry Birds game, where there are different birds set for each level. So let's develop a solution for that now. I can solve this by using a so-called property list file, or short, plist. I will create this in my levels group in the project, so let's right click and select new file. If I then scroll down in the templates, until I reach the resource section where I will, amongst other templates, find the property list, and that is what we are going to choose. I will call my property list levels, since we will only need one plist here. There won't be a level _1, level _2, plist, and so on. We will just add all levels in one file. By default, the property list contains one empty dictionary. I will now add one dictionary entry for each of our levels. I'll just click on the little plus sign here, just like in the info.plist when we added the new entry, and I will call my first item level _1. The type for this new item will also be a dictionary, so that we can add different properties to our level that we can later query in our code. The first, and for now only entry for our level, will be an item called birds, and it will be an array type. So let's write birds and select array for the type. I can then just add all the different birds that I want to use for this level 1 in our case, as entries to this array. So I'll just add 4 items in this array here. And the type is automatically correct since they will actually be strings. I will specify the names for the birds in a way that we can later use them easily with the raw value initializer again. Therefore, I will just write the lowercase color names, just like we used them before. So red, blue, gray, and yellow, which will give me 1 bird of each kind for the first level. I can then add the entry for our second level. Since we also have the SKS file here, I will obviously call this entry level _2, which will also be a dictionary, and it will also have 1 entry called birds as an array. The cool thing is, we don't even have to use the same number of birds in each level. So for this second level, I could only have 2 entries, and maybe they are both blue. So let's just add blue 2 times. This concludes our plist for now, and we can test it. However, we do need a way to load and read this plist file to actually be able to access this dictionary with the level data in our application. A good place to define the dictionary itself would naturally be our configuration file, where we did set a lot of general settings and constants. Right above our structs for seed position and physics category, I will create yet another struct, which I will just call levels. This level struct will only get 1 type property, which will be static var levels dictionary. And it will be dictionary with string keys and any values. I specify the type any for our values, since we will maybe add more data to this dictionary later on, and this way we are safe to do that. We now have a dictionary in our code that allows us to save the data from our plist file. But where are we going to do that? Since the data we load here will be crucial for our app to work, we should load it as fast as possible when our app starts. We can already load all this level data while we are still in the menu, so that as soon as we start a game, it will be ready. We can load something at the very beginning of our app's launch if we go into our app delegate file and add the appropriate code inside of the first method here, which is called application.finished_launching with options. This gets executed once our app launched, and we can just add the code here to read our plist file and save data to the new dictionary variable. But how does it work? I will first need a URL that specifies where our plist file can be found in our project. Since this is optional, I will use an if-let statement by writing if-let URL, and I will then try to set this to bundle.main.url for resource, and I only need the one with resource and extension parameters. For the resource, I will say levels, which is how we call the plist, and for the extension, I will pass plist. This should give us the URL for this exact file, levels.plist. I only need to add my code inside of this if-let statement now, since this is where we can access the file. I then need to read the data from my plist file, and this can also fail. I will use a do catch block with a try statement. I'll write do, and in this do block, I will try to save my data. If this doesn't work for any reason, I will add the catch block below, which will just get a print statement for us that outputs the error to the console so that we are able to debug if necessary. We can then work in the do block, and we will begin by defining a constant that should be assigned the data from our URL. I'll call it data and set it to try data with contents of URL. If this works, I now have the raw data from my plist. but I do have to make sure that I can get this data in my levels dictionary. Since this also can possibly fail, I will use a guard statement to convert this plist data to a dictionary format by writing guard let levels dictionary, which will be set to try, property list serialization.property list. And I will choose this method with data options and format parameters. For the data, we will obviously pass the data constant we have just set. For options, I will pass an empty error since we do not need any. And finally, we will need to add a format. Again, we don't need anything here, so I can pass nil since it is optional. I do, however, want to cast the result of this call, which is why we need our guard statement. So I will append the cast as a dictionary with string keys and any values. If this doesn't work, I will, in the else part of this guard statement, write print and then pass could not initialize levels dictionary and also, with return false, abort the method. This way, we can in our console see if anything doesn't work here and are able to abort it. If this does work though, and we successfully initialized a dictionary, I want to set this dictionary for my type property of levels. Therefore, we do levels.levels dictionary and set it to levels dictionary. If our app would now start up without any errors, I can safely assume that this property levels dictionary of the levels struct contains a valid dictionary with level data. But we aren't done just yet. We still need some kind of class or struct for our level to make sure we are able to correctly load the levels in the game scene itself. Therefore, I will begin by creating a new type for level by right-clicking on my helper files group and creating a new file. It will be a Swift file and I will call it level. Inside of the file, I do not need the SpriteKit import this time, since this will just be general Swift code to read our dictionary basically. I will create a struct with the name level that I can then use to prepare the data from my dictionary for the game scene. I'll begin with the property birds, which will be a string array. We will not yet initialize our actual bird instances here, but just pass the bird names in an array that we can then later use to initialize the nodes. I will also need a custom initializer, since I do not want to set the birds manually. I want to initialize level with a number, so maybe 1 for the level 1. Since this can, with our setup, fail, I will use an optional initializer, so after the init keyword, I will add a question mark. It will get one parameter level of type integer. Inside of the initializer, the first thing I need to check is whether we can get a dictionary for our specific level by writing guard.level dictionary, which I will try to set to levels.levels dictionary, where I now obviously want to access the dictionary containing the level that I passed to the init. So for the subscript, for the key, I will add the string level underscore and then append the level parameter. I also want to cast this as a dictionary with string keys and any values. And if this fails, I can in the else part simply write return nil to fail the initialization. But what exactly are we doing here now? Well, the levels property from the levels struct contains the dictionary with all of our levels contained. When initializing a specific level though, I will of course only want the dictionary for this exact level, which I can access by getting the value for the key level underscore 1, level underscore 2, or whatever level we need from this complete dictionary. If I take another look at my plist, this might make more sense since we see that the value for these keys is exactly these dictionaries. containing our level data. I have now retrieved this dictionary, meaning for the level 1, for example, I would have this dictionary with the birds array as an entry that I can now continue to work with. If I have the dictionary, I can then initialize my birds property, which will be done with the guard statement. Since the dictionary subscripting can of course fail, so we can do guard let birds is level dictionary at the key birds. Like we just saw, this is the key in the dictionaries containing the birds array. Therefore, I also want to cast this as a string array, since that's what it should be. Just like above, I will in the else part, if this fails, add return nil to fail the initializer and abort initialization. If we succeed by getting our level dictionary and then our birds array, I can finally set self.birds to birds. And I've then initialized my level instance by having set its properties. We almost made it. We did a lot of groundwork and prerequisites, but I can now finally go back to the game scene file, where I will modify how we are setting our birds property here, containing the array of birds that we have. I'll begin by modifying the property definition, where we as of now have just hard-coded some bird instances, by just initializing it as an empty array for the type bird. I will add a new property for the class that should always contain our current level. I'll add it right below anchor as a property level of type integer. It will be optional, and we are going to set this from our scene manager delegate before presenting the scene later. I can then scroll to my didMoveToView method, where we will now check for a valid level value and then try to initialize our level properly. I'll start with guard let level is level to get a non-optional value for the level property. If that is not the case, I can then directly return to abort any further loading of our scene. Below, I will add guard let level data, which I will try to set to a level instance for the level. In the else part, I will again return from the method. We do need this guard for the initialization of the level data constant, since like we just implemented the initializer, it can fail. Actually, since I have just called this level data here, which makes a lot of sense and is descriptive, it would probably be better for understanding to also call our struct level data instead of just level. So let's just rename the file and the corresponding parts in the file. So at the top and the struct name. This just makes a little more sense and describes it better what the struct actually is for. And it is for providing data for the leveled. So this makes sense. Back in the game scene, I will of course also need to change it here to get a level data instance. If I do have this level data instance, I do now know what birds we will need in the level, and I want to add them to the birds array of our scene so that we are able to use them. I'll do this in a for loop with for bird color in level data.birds, and then I want to initialize a new bird for each entry, and I'll begin with if let new bird type is bird type, which I will try to initialize with the raw value bird color, so red, blue, yellow or gray. If I do get a valid type, I can then initialize new birds or a new bird and directly add it to the birds array by writing birds.append and then create a new bird instance with the type new bird type. After this for loop, I should now have added all the birds that I've specified in my plist. They will all be part of my birds array, and therefore I will be able to have them inside of my level. So let's test all of this, since we did quite a lot now, And it's time we run our app again. We did add a new struct with the type property as the levels dictionary to our configuration file. We created the levels plist where we can add all the data for our levels. We loaded the plist data to our dictionary or saved it to our dictionary in the app delegate file when the app starts. And we created the level data struct to be able to load data for an individual level. And finally, we modified our game scene to load the birds in the didMoveToView method. Now, all of this effort is hopefully going to pay off, and we still need to set the level property on the game scene. Like I said, we'll do it in the GameView controller in the extension for the Scene Manager delegate. Inside of the present game scene for level method, I will now, other than setting the Scene Manager delegate property, also set the level property by writing GameScene.level and setting it to the passed parameter here. Alright, finally, let's run the app and take a look if we get the correct birds for the two levels. Let's begin with the first level, where I should get one bird of each color. I'll just skip through my birds quickly. So we had our red one, now we get the blue bird, and next will be the gray bird. And finally, we got our yellow bird, which is perfect. And that's exactly what we wanted to happen. Let's just try the second level, but we should just get two blue birds. And let's start, and we can see that we start off with a blue bird. As soon as the second bird spawns, we get another blue bird. If I also launch this one, we don't get any new birds. So our level data structure is working perfectly. And all of this hard work really did pay off.